Now we'll see this topic chemical analysis. इसको हम analytical chemistry कहते हैं. We also say analytical chemistries. So what is basically meaning of chemical analysis? So by their literal meaning, so it is just conveying that analysis means we are doing some analysis of chemicals. Yes, chemicals means definitely the reactions, means how much weight is we are taking, how much numbers we are taking. So there are different methods to understand, to know their amount. So it is a study of different methods used to determine the composition of the unknown substances. So this is the basically meaning. So under this heading, so there are different type of analysis. This is not a single, there are different type of analysis. So we'll see one is called as qualitative analysis and second is quantitative analysis. So these two are different. So by their meaning we can understand qualitative means what and quantitative means little meaning little bit understood. Qualitative means it based on quality, it is based on quantity. So quantity. So here qualitative means what type of quality is a quality. So to know about the nature of constituent. Here constituent means like elements, molecules, ions. So these are present in the matter. So we know what type of constituents are present, or we can say to detection of ions, it is a positive, it is negative charge, negative positive. These type of analysis are mostly done in the qualitative analysis. But in quantity we are not knowing this plus or say cations or anions, but we are knowing the quantity of the particular component present in the substance. So here we are dealing with the quantity, number, amount. So under this heading we are going to discuss it. So under this heading there are so many type of even quantitative analysis in which we determine the amount of the particular substance. So we'll see here. So one is called gravimetric analysis, then volumetric analysis. Another name of volumetric analysis is tachymetric analysis. Then eudiometric combustion analysis. This is another type of analysis, eudiometry. So then one is spectroscopic analysis or spectra analysis. So there are different type of analysis. So what is the meaning of, first let us see what is the meaning of all these type of analysis. So one is gravimetric analysis. Here we measure the mass of the solid substance, precisely mass. So mass means how much amount of substance, may be atoms, molecules, in the terms of atoms, element, compounds. So we used to measure mass. Here in volumetric, so it is based on the measurement of the volumes of the reactive substances. So when these volumes of reactive substances react to each other, so we used to measure how much volume has been reacted. In eudiometric or combustion analysis, so here reactant undergo combustion. So in combustion we try to find out the composition of the gases mixtures, okay, or molecular formula of the gases. So under this heading we have discussed in the sections also in eudiometry separate sections. So we can you can see that sections and understand what is eudiometry along with the so many types of problems. Now next is spectra analysis. So in this spectra analysis we are using a device called spectroscope. So spectroscope is an instrument or device, you can say, so which analyzes the spectra of atoms, ions and molecule spectra. So we using some particular electromagnetic radiations. So this analysis, with the help of radiations we analyze the spectrums. So this is not in our course, so we will not study too much. Spectrum is not in our lesson, in our syllabus. So this analysis is not in our syllabus. Eudiometry already we have given in topic separate, you can see this one. So and gravimetric analysis is the to measure the solid substances precisely. So this we have discussed in the stoichiometry while of stoichiometric calculations. So in that we have solved the mole ratio, volume ratio, mole volume ratio. So this we also discussed. So one left, that is called tachymetric analysis. So this is basically a pure tachymetric analysis that we are going to discuss today. This is our main topic of this whole lecture. So under this analytical chemistry, so we will use two concepts all the time. So one concept is called as mole concept, in which we use moles and millimoles And second concept is your equivalent concept. So equivalent and equivalent. So we also discussed mole concept in previous lectures and equivalent concept in previous lectures. So if you want to see these two concepts, you go through my previous lecture, mole concept and equivalent concept, along with the numerical sections. So it will be well clear what is equivalent concept and what is mole concept. So our volumetric tachymetric analysis is the application based. So we will apply this concept in volumetric analysis. So let us take one example. So this is A and B2 are reactant. They will react each other with certain moles, and they will form products C and D. So coefficient of C is to C and coefficient of D is small d. So in terms of mole, we can say A mole reacting with the B moles, they will give you C mole and D mole product respectively. So if you take mole ratio, so mole of A is to mole of B will be equal to A is to B, or we can write here mole A by A equal to mole B by B equal to mole C by C or equal to mole D by D. So this mole ratio is constant. Or we can convert a mole ratio in terms of molarity. So molarity A into volume of A. So this becomes nothing but the mole of A. Similarly, molarity B into volume B, it will be B. Molarity C into volume C, it will be C, equal to molarity of D into volume of the substance D by small d. So it is same only. This is a mole concept. Now come to equivalent concept. So in equivalent concept, we can say that equivalent of A is equal to equivalent of B equal to equivalent to C is equal to D. So this is the law of equivalence. So one equivalent or number of equivalent of each, number of equivalent of A equal to number of equivalent of B equal to number of equivalent C, number of equivalent D. So it can be 2, 4, any equivalent can be possible. Whether all are 2, whether all are 4, all will be equivalent to each other. So this is the law of equivalence. Or we can convert equivalence of A in terms of normality also. Normality of A into volume A is equal to normality of B into normality of volume of B equal to normality of C into volume of C and normality of D into volume of D. So these are the concept we will use in the analytical chemistry. So let us take one example to understand this concept, analytical chemistry concept, by using mole ratio method and equivalent methods, concept methods. So 40 ml of 0.5 molarity silver nitrate solution mixed with 70 ml of 0.3 molarity barium chloride solutions. Calculate the mass of silver chloride form. So this through mole concept SU and equivalent will try to solve this problem. So write here silver nitrate barium chloride and it will give you silver chloride barium. So write the whole equation. Okay, now balance it. So this is 2 silver nitrate, this will be 2 AgC, balance it. So here, so initially before reaction, this is 40 ml, 0.5 ml, 0.5 molarity. So you will get here 20 millimole. Similarly, 70 volume, 0.3 molarity here. So you will get 21 millimole. So after reaction, whatever this is 20 millimole, this is 21 millimole. So for 1, we require 2 moles of silver nitrate. So for 20, we require 10. So 20 minus 10, so 11 millimole barium chloride left behind. So we will get here. So this is 20 millimoles, definitely we will get 20 millimole, 10 millimole. So 20 millimole is what is the mass of silver chloride. So this 20 millimole is written by a W by M. This is the mole into 1000. Okay, so we will 1000. So 20 is given here, weight, and the molar mass of silver chloride is 143.5. That is 107 plus 35.5. So we will get here mass 2.87 grams. So this is the using the mole ratio methods. Similarly, we can solve through the equivalent concept method. So in equivalent concept method, we see here same problem is there. So in this silver nitrate barium chloride silver chloride, so where there is no need of balancing the equation, that we know previous also. Here there is no need of balancing the equation. So we use the concept of n factor here. Instead of balancing, we use n factors. N factor in this case is 1 because the charge of the silver is 1. Here charge of the barium is 2. So milliequivalent before reaction is 14 to 0.5, that is 20 milliequivalent, and here 17 to 0.6. Why 6? Because molarity of the barium chloride is 0.3. So if you remember, molarity of the barium is, I am showing you here, 0.3 molarity, and normality is equal to molarity into n factor. So here molarity charge of the barium is 2, so it will be your 0.2 into 3.6. okay, So it will be 42 milliequivalent, so 20 milliequivalent and 42 milliequivalent. So law of equivalence says that they will be equal to each other. So this is greater, this is lesser, so this will must be 20 for reaction. So we require only 20, so 20 milliequivalent is left behind. This is excess quantity. So here we will get 20 milliequivalent silver chloride. Now milliequivalent silver chloride is 20, which is nothing but the weight of silver chloride by equivalent weight of the silver chloride multiplied by 1000. So again, equivalent weight of silver chloride is 143.5 because n factor is 1. So if you solve it, you will get again same answer. So through mole ratio and through equivalent ratio, both answers are same. You can see here, these are also same, this also same. Both are same ratio. So this is the way of solving the mole ratio method and equivalent ratio methods. Now come to our topics, gravimetric analysis. So what is this one? So we know this is the based on stoichiometric calculations. So little bit we will know actually what is this. It is the most accurate and precise method of macro quantitative analysis. So we are doing macro quantitative analysis, means main analysis in large quantities. So we have analyte, some compound is given, so we have to know the mass of that compound. So first it is converted to insoluble form selectively. We make insoluble form selectively. Now this insoluble form is separated out as a precipitate. It is dried, then it is ignited and or converted to some other form. And that form which is dried is accurately weighed. Properly it is weighed, and then from the mass of the precipitated, means this one, and knowledge of the chemical composition, what kind of composition was there, and the mass was collected, precipitated. So we try to understand how mass of the analyte in the desired form. So how much mass was present after calculation, we get after from the analyte. So this much mass was present in the analyte. So after doing this calculation, so let us take one example to understand things, because this is too much theory, we cannot understand. Here I brought one example, simple examples. 0.455 gram sample of plaster of Paris calcium sulfate dot half molecule of hemihydrate. So when treated with the excess of barium nitrate gave 0.617 gram. Okay, so after reaction it gives 0.617 gram. Anhydrous barium sulfate. Calculate the percentage of calcium sulfate in the sample. So we have to find out the percentage of calcium sulfate. So this is the quantities here, and we have to find is giving. This is the after precipitation or dry, it is given 0.617 gram. And from this 6.617 gram, we have to find out the calcium sulfate here. How to find out? So this is our chemical reactions, calcium sulfate on reaction with the barium nitrate. So they will give you barium sulfate as a precipitate calcium nitrate. So this precipitate taken out. So balance this equation. On balancing we will get here, if you take mole ratio, so 1 mole of calcium sulfate after reaction, it is giving you 1 mole of barium sulfate as a precipitate. Okay, so after this precipitate, so if you weigh it, this is the molar mass is 136 gram and this molar mass is 233 gram. So weight we are giving how much, this is 0.617 gram. After treating, it is giving here 6.617 gram of anhydrous barium sulfate. Okay, so for this 617 gram anhydrous barium sulfate, how much calcium sulfate we require? So for this much gram, we require 136 gram of calcium sulfate. Now for 0.61 gram, how much we require? So just you do 136 by 233 into 0.617. So you solve it, you will get 0.36 gram calcium sulfate was required. So what is the percentage purity of the sample? So it is very easy. Now we know the accurate weight of the calcium sulfate, and this is the impure sample. So take the ratio and multiply by 100. So we will get here 79.15%. So this is the way of solving the gravimetric analysis. So these topics here we end.